All right, so today we're going to solve. You guys have actually solved these for a long time. They were never called rational expressions before, but you've been solving these. These typically were set up as just proportions for you. So the key here is for us to get this as like a proportion. So one fraction equaling one fraction. If we can do that, then we can solve using by cross multiplying and solving. Okay? So, number one, 3/8 plus 4/5 is equal to x over 20. Oh, no. We can't do that. This is 3/8 plus 4/5. What should we do with 3/8 plus 4/5 probably?
Make them the same in the bottom.
Okay, so give them the same denominator. So 8 and 5, what does the denominator have to be? 40. So this first fraction we're going to times by 5. Second fraction we will times it by 8. Okay, so 5 times 3, 15 over 40. Plus 4 times 8, 32 over 40. This is equal to x over 20. So 15 40ths plus 32 40ths. What is that? 15 and 32? 47 40ths? It's equal to x over 20. We could cross multiply and solve, but that's doing one more step than what we need to do. How can we just get our x alone here? Just do what? Just multiply by the 20. Right? If we multiply by the 20, this 20 cancels, so we just have our x alone. If we multiply by the 20, we can think of it as 20 over 1. Can we reduce the 20 and the 40? To what, 1 and 2? So our answer would be 47 halves.
Can we just cross multiply if that's easier?
Yeah, you can cross multiply and solve it if that's easier for you. That's perfectly fine. Yeah, there's a whole bunch of different ways how you can solve these. As long as you're doing completely legal math moves, you're fine.
Wait, there's illegal ones?
There's very illegal math moves.
Like what? Like burning your homework.
Okay, number 2. X over 4 minus 4 over x is equal to 0. Mm-hmm. Which is the same as 47 halves. 23 and a half is the same as 47 halves.
How do you put your calculator through fraction decimal?
Did you divide by 40, Ellie?
You can make it plus.
Okay. All right, number 2. X over 4 minus 4 over x is equal to 0. Ideas.
Make it
What?
positive. Make it positive.
Isn't that one?
Make it positive.
No.
Make it positive.
These are on the same side, right? No, these can't cancel because this is a minus sign. Can I get one fraction on one side and one fraction on the other side? Yeah, I can do that. I could add the 4 over x over.
That's what I said.
That's what you... Okay. I was confused by what you were saying. So now we have x over 4 is equal to 4 over x.
Now you
Cross multiply and solve. Okay. So x times x is x squared is equal to 4 times 4 is 16. Take the square root. X is what? Just 4?
Plus or minus 4.
Plus or minus 4.
Plus minus 4.
If you ever want to know if you did the problem correctly or not, just plug your values back into the original problem. We added this. We didn't flip anything. We added the 4 over x to the other side. So we could have one fraction equaling one fraction. Okay? Is this okay?
Yeah.
Let's look at the first example on this page. X over 8 minus x over 12 is equal to 1/8.
Alright, so you add the ones. No.
You put it over to the other side.
Okay, which one should I move over to the other side? Probably the x over 8. Now, why would we decide to move the x over 8 over?
Because they're the same denominator.
They already have the same denominator. So I'll subtract the x over 8 over. So now we have a negative x over 12 is equal to, how would I write this as one fraction?
Wait, how do what?
X plus
1 minus
X over 8.
over 8.
Wow, you're really late.
Okay, so cross multiply and solve this now.
Two x's though. There's two
That's fine. So this first, that'll be negative 8x is equal to,
12 minus 12x.
good, 12 minus 12x. What would we do next to solve?
Add the 12 to the other side. Yeah.
Okay, so we'll add the 12x.
9, 10,
You get 20. No, you don't. Just kidding.
4x whew, equals 12, so what is x?
3.
3.
I don't know how to divide, so I would be stuck right there.
Is that okay?
Just playing it.
Okay, number 4. I don't think we really need to solve this as a class. Do you see what you would have to do to solve number 4?
Yep. Yep.
Tell me the strategy that you would use.
I times them all.
Yeah, you would just cross multiply and solve it. Okay, so that's already set up for us. We won't do that one together. Instead,
We're going to do it now.
we're going to skip to this one.
I'll add number. Oh, this one.
Sorry.
X.
Hold on. X over x plus 4 minus 4 over x minus 4 is equal to x squared plus 16 over x squared minus 16.
Do you have to take the square root of the equals part and make it all the same denominator?
We wouldn't take the square root. We'd have to take the square root of both sides, and then it would get very, very ugly.
Scratch that.
So I don't think we should do that. We want to get one fraction equaling one fraction here. Okay.
Fat tax.
So we certainly could factor that. How's that going to help us get two of these fractions written the same?
Control delete.
Okay. Could we just combine these two together somehow? So let's maybe try to combine these first two fractions together. So x over x minus 4 minus 4 over x minus 4. So this is an x plus 4. That's an x minus 4. I want to get these so that they have the same exact denominator. So what would I have to times this first one by?
Negative.
By each other.
By each other. So I times that one by an x minus 4. And this one by an x plus 4.
Oh, you could just cancel them out because they're going to equal 16.
Well, we can't cancel yet.
Well, you can.
So, okay. X times x minus 4, what does that give us? X squared minus 4x. What's the denominator going to be?
X squared negative 16, so you can't. Oh,
X squared minus 16. What happened to the outside and the inside? They canceled, so that's why we have x squared minus 16. Minus, next fraction.
X minus 4x plus 16.
Yep, 4x plus 16 over x squared minus 16 is equal to, right-hand side didn't change, x squared plus 16 over x squared minus 16. Can I now combine these two fractions together? Yep, they have the same denominator. I'm subtracting, so I want to make sure I'm careful about how I combine. So I'm going to add the negative throughout.
Oh, x squared negative 8x
Minus 8x
negative 16.
is equal to,
X squared over 16.
yep, x squared plus 16 over x squared minus 16. Okay, now, who wants to cross multiply this?
Not me.
So let's think about some other things about fractions we know. If I have x over 5, and I say this is equal to 3 over 5, what does x have to equal? 3. Why does it have to equal 3? They have the same denominators. Do we have the same denominators? Okay, so we have the same denominators. So can we just make our numerators equal to each other?
You can just like go across. Like,
Yeah, exactly. We can just go across. We can say x squared minus 8x minus 16 equals x squared plus 16. So we can, because our denominators are the same, we can just look at the equation that our numerators create. Okay, so x squared minus 8x minus 16 is equal to x squared plus 16. How would we solve this? We got to get like terms together. Okay, so we'd add the 16. How about these x squareds? They're going to cancel. When we go to subtract x squared, they cancel on both sides. So we end up here having a negative 8x is equal to 16 and 16? 32. So what's x here?
4.
Negative 4. Now, we did not take into consideration the denominators when we were combining these. So we do need to take in consideration the denominators to check our answer and make sure that it's a solution that will actually work. So if x equals negative 4, specifically looking at the denominators here, if x equals negative 4, does anyone see a problem that will happen with one of our denominators? Yeah, what's the problem? Negative 4 plus 4, what does that give you? 0. Can we divide by 0? No. So because this would make that a 0, that actually doesn't work. So this ends up being a no solution. Okay, let's do another one that involves, a similar type of process to this. But we'll get a solution. Let's see, is it that one? Yeah, we'll do that one. X over x squared plus 3x minus 4 plus x plus 1 over x squared plus 6x plus 8 equals 2x over x squared plus x minus 1. So we want to get same denominators here. I don't think any of us really want to multiply these three together. So what's another way we could do this to make it simpler? What could we do with each of those denominators? Factor them. Yeah. So take each denominator and factor each one. Hopefully, they will have some terms that are alike. So x squared plus 3x minus 4. We know it's x and x, and then how does it factor? Yeah, plus 4 minus 1. X squared plus 6x plus 8. Yeah, x plus 4, x plus 2. X squared plus x minus 2. Yeah, x plus 2x minus 1. So now, take a look at this. We want to make all the same denominators the same. So we have to take a look at the two factors we have and what factor is missing from it that the other fractions have. So this first one, we have an x plus 4 and an x minus 1. It's missing the x plus 2. So we're going to take this one and times it by an x plus 2. Second fraction, what is it missing? Yeah, it's missing the x minus 1. So we'll take that fraction and times it by the x minus 1. Third one, what is it missing? The x plus 4, so we'll take this one and times it by the x plus 4. Now, are all the denominators the same? Do they have the same three factors in now? So if all the denominators are the same, what can I look at? Just the numerators, okay? So x times x plus 2, what will that give us? Go ahead, x squared plus 2x plus x plus 1 times x minus 1. Yep, x squared minus 1. What happened to the outside and the inside? They canceled with one another. And then equals 2x times x plus 4. Plus. All right, we want to get our like terms together. So here I'm going to combine the x squareds together. So we will say we have, oh, that's awkward. There we go. 2x squared plus 2x minus 1 equals 2x squared plus 8x. Now what else would I have to do to combine the like terms? What cancels? Yeah, the 2x squareds, when we go to subtract that from both sides, they cancel. So we have 2x minus 1 equals 8x. Yeah, so subtract the 2x. So we have negative 1 is equal to 6x. Divide by 6. So what does x equal? Yep, negative 1/6. Now, will this make any of your denominators 0? No. What are the three values that would make your denominator 0? Yeah, negative 2, negative 4, and positive 1 would make those 0. So this is a perfectly fine solution. This is obviously the harder type of problem that you're going to see. Okay? Is this okay? Now, as long as you are doing legal math moves, you're going to get to the same ending result. Anytime you do anything illegal, what would be an illegal math move? Okay, stealing the answers, yeah, that'd be illegal. But a more algebraically illegal move would be only not multiplying the numerator by the same thing you multiply the denominator by. Okay, so if you multiply the numerator, make sure you multiply the denominator. If you have to solve by factoring, make sure you set it equal to 0 first.